lack of what are the academia producing in terms of research and research results, and what industry is creating. What is this? Is basically the loss in translation concept. We focus in academia, why this is important, while companies typically ask how we can make value out of that. And those two kind of confronting perspectives of how the research works create this, what is called as a valley of death. In academia, we focus very much on what is now. It's on my right-hand side and your left-hand side. So most of the activity there in discovery, basic research, a lot of funding, publication, and so on. And as long as we move to if you are familiar with TRL scales, the academia fails its interest. Companies typically are in the product development and production. This gap here is the applied research where I want to focus and emphasize today. So how we can actually bridge the results from the academia to bring innovations and great potential in industry, and how to bridge this valley of death. There is a new course of research, which is also defined as a new ABC of research, primarily that combines three core dimensions of human intelligence, like scientific thinking, design thinking, and engineering thinking. We need all three of them to be combined together in order to work and to bring this added value. And the added value should not be only in terms of theories, in terms of published papers, but we should also provide a solution to the given problems. For doing that, academia alone cannot work. We need to cooperate together with industry. We need to establish different life cycle strategies to work with industry together in order to create the added value where the academic research and research results bring to the solution and potentially new products and developments in the industry. How that could work is this concept of the co-production. In Sweden, we have a funding agency that actually finances universities to work together with companies. And for doing that, we need to co-finance, meaning that the university gets some money, but the companies need to chip in terms of time, not money, in terms of time in order to work together. How does that work? Of course, academia needs to build a scientific agenda. How does the scientific agenda related to that particular problem evolves? And that scientific agenda needs to be in line with a company agenda. What is the problem? If we say that in academia we try to work with companies, we typically go in there and say, well, I research about this and that. That's not the way to work with companies. You need to approach the companies, what is the problem that you have? Do you produce more scrap, or do you have problems in this or in that? So that kind of things needs to be to collaboratively create a joint scientific problem. And then you have the collaborative research part that needs to happen together between the industry and academia. And the result should be dual. It should be a solution to the problem that the company initially came in, but also it can generate scientific publication for us, because there are plenty of venues where we can publish like that. So this is something that is quite important in order to start working to bridge that gap that exists on the valley of death. And applied research is something that I'm very fond of. So what is applied research? Applied research focuses not on a scientific, directly importance of phenomena, but on the problem, real-life problem. And how to solve that real-life problem? You generate a scientific agenda. We have an example that I have been working with Siemens. And in Siemens, they had a big problem because most of their design of the gas turbines have been based on prints and not proper version control, and how to integrate that in a kind of 3D pipeline of data that can be visualized and interactively worked has been a challenge. Together with them, we have established a research project when I was working at RISE, Research Institute of Sweden, and we have developed a prototype. So applied research is not directly only on producing another publication. It's about producing and materializing the piece of research into something tangible and communicatable in form of tests and demonstrators that the companies can and find use. Today, as a result, this idea has been spin-offed into a company, and that prototype is now being used in Lincoln, UK, Finspång, Sweden, and Berlin, Germany, in 3 sites. Another example, see-through mast. We had a Toyota came to us and said, well, we have a problem with our forklift drivers. When they drive a forklift, when they put a mast in front, they can't see, which means that they need to drive backwards, and they started having ergonomic issues on the back. How to solve that? And then we set up an applied research project where we developed a concept note trying to see introducing a thin screen in front of the a forklift, a wide-angle camera, a computer with the capture card of the feed, and a Tobii eye tracking. So an eye tracking device in order to follow the gaze, simply to be able to mimic the user perspective rendering. In order, if you are looking in that direction should be coming to the screen presented. And this has been a research that was done in another application that we did with drones. So we kind of combined that piece of knowledge from a different domain and applied it here. When we started implementing with that, we came to the problems. The problem was the latency of the eye tracking hardware. It didn't respond properly. It has a latency of 1 second, which is sufficiently to give it a bad user experience for the forklifts. So we needed to go back to redo the research, and what we came up with a solution, introducing a HATS to the forklift drivers and introducing an infrared tracking. And infrared tracking came from a gaming technology. So completely unrelated field of what this was the problem. So infrared tracking, and then we are able to develop this prototype. As you can see here, that was presented in the CMAT fair. And what was the good thing of this? That this has been done with a team of 8 researchers together with me, and it did not cost that much. If you really are interested how much it cost this research of 8 months, we can discuss it later. But it didn't cost that much, and the CTO of Toyota from Tokyo came to our offices and meet us after this. Another example now in the public sector, digital pathology. In Sweden, we have a major problem when it comes to having pathologists. God forbid, if you're a cancer patient, your waiting time can be between 11 days and 2 months, depending in which region in Sweden you live. Now imagine the stress that you can have while waiting for the results to come back, simply because the kind of tissue sampling process has been done completely manual. And the technicians needed to draw, take a piece from here, and make notes in a piece of paper. When the paper transferred to another person, like a doctor, he had comments, well, should I look at it as a landscape mode or a portrait mode, in order to know in which part of the organ the tissue has been taken. So it was so much delays in this miscommunication process. So what we did is that we developed a research based on a research thesis, PhD thesis, that was published in the Linköping University on the kind of short-range magnetic tracking. And consequently came to the solution that we introduced this magnetic tracking underneath the regular tables in the medical aspect, worked with LRI Olympus that provides medical scale cameras, developed a software that can capture card, and in order to have hands-free, we magnetized the scalper, and we introduced the foot pedals from the game consoles. So the technician, instead of using hands for taking and making pictures, he or she could use the foot pedals in order to zoom in. And this was combined with augmented reality. The picture doesn't look very good here, but you can do the measures, and you can kind of annotate all the samples that we do. After, this prototype was financed through a Swedish innovation agency called Vinnova, and it's now actually as a prototype at Center for Medical Imaging and Visualization at Linköping University, which is one of the largest university hospitals in Sweden. Just for the sake of ethics, we have not tried this with a human tissue. It was only with banana and Play-Doh, so just so we don't have that misunderstood. So what this shows is that innovation happens when disciplines meet. It's not anymore to innovate within its own field. You need to meet with other disciplines. There where the innovation happens. You need to work on the disruption through innovating with prototypes, showing how things work, not slides, not papers. In paper, everything could work but when you do it hands-on in practice, there when you need to show that the things work. And the focus on the value creation. In the first one was speed up the design process. In the second one is better ergonomics for the forklift drivers. In the third one was speed and also a better process for the medical technicians to prepare the tissue samples. So all these are taking the end user and beneficiary into a focus while doing the research on applied things. Of course, now we will say, yes, this sounds very good, but we don't have all the instruments yet here. Here are some examples what could be the instruments that can cooperate between universities in Kosovo and industry and the business sector in Kosovo as well. The first one, industrial PhD studies. Identify real-world problems that industry is facing. Make them as a research programs and the people in academia can work with. We have now a program in our university where the PhD candidate is employed by the company, but it's enrolled in the university in order to conduct his PhD studies. During the 100% of his or her time, 20% he or she works only for company. 20% he or she only works with research papers and courses that he needs to finish. And the 60% is the overlap, where the candidate works with values for both the company, but also contributing to his research. Now, what are the benefits for the companies? For the academia, of course, it's good. You have a more research power, you can bring more ideas. But for the companies, is keeping and building the expertise. I think there is a saying that the price of knowledge retention is usually far more lower than the knowledge acquisition. So acquiring new people with more advanced skill set will be a more costly part. Second, recruit new employees with a deeper knowledge in the domain. What that can mean? It means that it will improve your moving higher up in the value chain in the product portfolio. Because in order to create value, it's not sufficient that we only develop. You only need to design and come up with a new creative ideas, where the margins are. If you only end up on outsourcing, where you sell your working hours, that is a limited resource. Because also in Kosovo, in Sweden, in Germany, the day has 24 hours. You can't sell more than 24 hours. Another example that we are currently doing, maybe some of you that have me in LinkedIn have seen, we are starting a new master program on interaction design. And what we are doing is that basically we are introducing the concept of academic internship in the terms of like designer in residence. What would mean that? Is that basically a student will be sitting for the 6 months in industry, in working in real life problems, in real life projects. And for that to be accredited with academic points, that will contribute to his or her degree after. What this means that basically the full second year, after finishing the coursework, can be placed in industry. Because students can do the internship, and finding an interesting problem, they can continue with the master program. What are the benefits for the companies, in this case, that we use as a selling pitch for them, is that they can have a constant contact with the new talents. I have used this approach when I was head of the research center in Norrköping. I constantly had more or less same amount of students as I had staff. But from the day one, they got a full treatment as a staff members. They got 24 hours access to our labs, a working place, and they were part of the family from the day one. They have finished their thesis, they have finished their projects, and 2 out of those I have recruited because I already knew. It was no problem to know if their skills fit. So you have a fast track, kind of risk-free recruitments. And the last, but I think it's crucially important, is nowadays career paths of professionals are not any longer linear. In our parents' time, you're supposed to finish your education, and when you finish your education, you will continue for 40 years or so, and they didn't have any changes in career, more or less within the same profession. Nowadays, the life is so dynamic. You need constantly to be upskilling. For that reason, university has a role here, but also companies need to work together to create these alliances for lifelong learning. How that can be done? We need to develop new programs jointly. Industry will know what it is happening out there, what are the needs. Academia should know what is like a qualified, high-integrity knowledge that needs to be delivered, and constantly focus on the labor market needs. If we detach this, we will be creating graduates that cannot be absorbed by the labor market, or their skills are not applicable into the labor market. And when we have this mismatch, you contribute to the unemployments. So for that reason, it's like, try to focus development of the programs that actually fits the needs in the labor market. I know just after, because I was finishing my education here in 2002, at that period of time, everybody wanted to be an economist or law. And even if we had the kind of Wall Street here, we would have potentially sufficient economists to be employed, but we didn't have that. So that kind of mismatch between what we need as a country and what we offer as a universities needs to be anchored. And cooperation between university and industry is crucial for these things. So I think that's all for me. Thank you.